CAN was invented by a German-based company called Robert Bosch in 1980 for automotive applications. The company dealt with like the development of automotive part and then the development of car. They involved in that activity. During their initial phase, most of them are mechanical. Like there is no exchange of information between ECU. They had a powertrain control module. They have other modules. Every ECU worked independently. There is no exchange of information, communication. Later, they used the technology that I told, the older one, the RS-232 communication. They simply exchange byte by byte between devices, between each electronic ECU that they had in their car. After some time, they felt that the data bandwidth is not appropriate and it is not enough for them to exchange the information, the sensor detail among the ECUs. Then they invented, otherwise they modified RS-232 communication to CAN communication. So the CAN already had a proven standard. From that standard, they come up with a new standard, the controller area network. That's all, nothing more than that. This CAN is an asynchronous one, asynchronous serial bus. The moment you hear about CAN, immediately the next judgment that you have to make is it is serial. It is not parallel. Even your TCP IP is serial. Most of the famous communication standard that we have today in the market are serial. The parallel doesn't have that much room. In today's world, the serial only has dominated every segment of the modern era. The CAN is serial one. That is the first advantage. Because of that, we don't need to have more lines, more physical line to transmit the data. Second, the CAN is asynchronous. It doesn't need any clock. There is no requirement of synchronizing the clock before doing the transmission. Why? In order to avoid the clock, they introduced few more bits called as start of frame, end of frame. These, when you have start of frame and end of frame, you won't have clock. That is called as asynchronous serial bus. The next thing is the CAN is also a differential one. Why? The first benefit that we have in the CAN is serial. The second benefit is it is asynchronous because we don't need clock synchronization to exchange the information. The third one is it is differential. Why we have to go for differential? What is the benefit that we will get when we use differential bus? Mostly this CAN is used in automotive units. Most of the automotive, the car used to move from one place to another place. Again, it used to go into different environmental conditions. When there is a movement, there will be a vibration. When there is a vibration, there will be a noise. When your vehicle moves to different environment, you will get a different sort of environmental noise. Those noise will affect the performance of your electronic device. Sometimes you will lose some of the bits or something like that. To avoid that, what they are doing means when they want to transmit a signal, they find the complement of the signal. You have original signal as well as a complement of that signal. Actually, they used a NOT gate here. In reality, it is not NOT gate. It is an inverter circuit because this signal is an analog signal. We have an original signal and we also have a complement of our original signal. Both of them are given to a comparator. When you give original and then inverse, you will get the original at the end. The comparator used to produce the original. But when you get a noise during the transmission, the noise will be introduced in both, like your complementary signal as well as in your original signal. See here, as they introduce this noise, the pattern of invert complemented signal is changed to, like, it created a zero crossing. When it is an original signal, the noise created a peak. When both of them are given to comparator, at the end, we have original signal, filtered signal. Actually, they used to call it as a filter, comparator. There are many names available for this circuitry. The ultimate goal is to cancel the noise. Why they go for differential bus? Why they create a complement of original signal? Because when you transmit the original as well as the complement and you are getting a noise, the noise will be introduced in both. Again, when it reaches the comparator, that will filter out the noise because the noise is available. The -1 + 1 is equal to 0, like that only. Noise is constant, so that you will get the original signal. If you just transmit only original signal without having any complementary signal, what will happen means your original signal will be distorted like this. It is having a peak here. That peak will give a different meaning. Without this filter, when you transmit that, this peak will come to the signal as well. So that will affect the performance of the device. Otherwise, even sometimes your device can malfunction. To avoid that, every time when they want to transmit something, they will also find the complement of that. That's why we have a CAN high, CAN low, two lines. When you hear about the CAN, you always see these two terminology, CAN high and CAN low. What is that? Actually, they are a same signal. In CAN high, you used to have original. In CAN low, you may have a complement of that.
I have a doubt.
Yes.
Is a differential signal is a digital or analog?
Okay, brilliant. As far as this circuitry is concerned, it is analog. But as far as the CAN is concerned, it is digital. The differential can be applied to both digital as well as analog. When it is an digital, it will be like pulse, either 0 or 1. When it is an analog, you will have a voltage like a 0 to 5 volt voltage waveform, something like that. It is a continuous in time. Whereas in case of digital, it's discrete in time. That is the difference between analog differential signal and a digital differential signal. But the character.
This comes under DC coupling. This comes
Actually,
under DC coupling or?
Actually, it is not for DC coupling. It is to filter out the noise.
Oh, okay. So it is mainly works for the filtering of the noise.
Yes. That's why they use it in CAN A and CAN low, because CAN is going to exchange the information digitally only. At the end, exchange information from one ECU to another ECU. You have one ECU, you also have another ECU. The exchange information between these at the end in physical line, the connection line that you have between these two ECU, you will exchange the information like voltage pulses. It's like a PWM waveforms, a square waveforms, which will go from one device to another device. Whatever information that you want to transmit from one ECU to another ECU, first you have to convert your digital information into voltage pulses. Then those pulses will go physically in the copper line and twisted pair line that will go from one devices to another. So every time when you are exchange the information, your creating a voltage pulse. That voltage pulse can be affected. It can be affected by the noise. So when it comes to environmental noise, the voltage pulses can be easily affected when using ESD or something like that, EMF, whatever that they are creating, the external induction noise, or there are many noises are available. Using those noise, if you simply flip one bit, that will give a different meaning. If you simply make your 5 volt to 0 volt by pulling it to ground or something like that, because of that, the entire meaning will change, because it should not be disturbed. Whatever that you transmit from one ECU to another ECU, it is like a series of voltage pulses, one after another. You are simply moving them out. Because of the noise, if any one voltage pulse is changed from 5 volt to 0 or something like that, the receiving end, you will get a problem. You cannot reconstruct what you transmitted. That problem will happen. That's why they are doing that. Reason why we have can high and can low, to avoid, to get the differential voltages, and then at the end, main goal is to cancel the noise. That's why we have a can high and can low. Even you can simply have a can, a single line, no problem, but you will be affected by the noise. When there is a noise, you will get a problem. It is like when you don't have any noise, your environment is perfect. In that case, we no need to go for differential voltage. There is no need of can high and can low. If you just have one line and you transmit a PWM pulses, voltage pulses, 0 for 1 volt and then 1 for 1 volt. If you do like that, it will work without any problem. The reason why we go can high and can low and we are creating a complement of the original signal, the reason behind that is to filter out the noise. Clear?
Yeah, clear. What is I think it is a IC integrated component at the receiver side, right?
Yes. This is to get an idea about how differential signal works, but this is not something that you can imagine in CAN. In CAN, it is something different. It's mostly a digital circuitry. This is to give why they go for differential in real time. For that, I gave this idea. Like initially, they have a signal and then they have an original and then complement. When that is transmitted over the line, they are introducing a noise. Because of that, your complement signal get this distortion and then original signal get a peak. When you pass your original and complement to the filter, your noise is filtered out, because you have the noise in both. So noise in original as well as the complement. So it will cancel each other, which is equivalent to +2 -2. So you will get at the end, you will get zero noise. They are able to get the original signal without any problem. I gave this diagram to make you understand why they are going for can high and can low. Why don't they use only a single can high or low? That's why I gave this diagram. You no need to imagine like there will be an op-amp circuitry and then there will be an AND gate. Even this diagram, this is not gate, this is just an without any not gate, right? You're just sending the signal, just amplified signal. So you cannot send an analog signal to a gate. That itself not possible. The reason why they put this one, they are trying to say that they are finding the inversion of this signal. This is equivalent to, there is an op-amp inverter circuitry available. When you pass any signal to that circuitry, it will give inversion of that signal. So here they have given this signal. So the inverter has given this signal. You no need to think like even our CAN hardware used to have this stuff. It will have them in a digital form. Because microcontrollers are digital devices, they will have everything digital devices only. There is no analog devices will be there in them. Okay, no? Clear? Shall we move forward?
CAN means is a cable, or we also have a RS-232, right? A microcontroller. It's like we have a box to convert, or it's just a cable. CAN means it's just a cable.
You can think the CAN as a communication standard. It is a method in which the informations are exchanged. It doesn't mean that you have to always use a twisted pair of wire. You can even do a wireless communication using CAN. CAN can be transmitted in a radio link or a wireless signal. No problem. That is possible. So similarly, RS-232 also can be transmitted in a wireless one. You can transmit them in fiber optic cable also. So CAN is a method in which you will transmit digital signal from one device to another device. RS-232 is a method in which you transmit the digital bits from one device to another device.
In cars, we are transferring the signals through the cable only, right?
Cable only, yeah.
There is no additional thing, or in practical way also, while we are implementing the signals, so we are using from test to PC to direct ECU.
Yes.
So there is nothing else in between them.
There is a cable,
So,
right? You are connecting.
Yeah, right, cable. So CAN is nothing but it's a cable. We can analyze like a cable, right?
No, the CAN uses the cable. CAN uses the cable to exchange the information. Okay, let me tell you like this. I can give an example. You are doing some of my task. I employed you. At the end of the day, I have to pay you. I am just giving you a paper. Whatever that we have money, the money that we have, right? It is just a paper. Is that right or not? Do you agree on that or not? The only thing is the governor has signed in that. Nothing more than that. Do you think that paper has some value? No. Actually, it has a fictitious value. Actually, it has a value. When it is a paper, when you see that as a paper, yes, it is a paper. That's nothing more than that. It doesn't have any value. You see, I am seeing that rupee as a paper. So it doesn't, if that is the case, can I call you are giving a paper to me? No, I'm not giving paper to you because I am using the paper as a means to pay you. In olden days, when somebody work for someone, they will give a gold coin. A fraction of gold will be given. A fraction of gold or a fraction of silver will be given. Because these are the money in those days. That means why they gave that gold or silver? It's just a metal. When you see that as a metal, it's just a metal. It is extracted from the earth. That metal has a value. In order to get gold or silver, you have to suffer a lot to get it. Also, they are having a demand in those days. The people has the demand of gold. It has a very great value. Even today, they have the value. The thing is, one person is giving his hard work to another person. It is not like he's just giving a metal. Inside that metal, he is giving his hard work. You worked for me, so that I am giving you my hard work in terms of this coin. The CAN is not a cable, CAN is not a box. No, not like that. CAN is a method to exchange the information. Ultimate goal of CAN is one ECU want to speak with another ECU. It want to infer, it want to give some information to another ECU. That's why we need a CAN. The CAN is otherwise you can say it is a language in which a two ECU used to speak. Calling a CAN as a cable or a box, that is not a right thing. It is equivalent to, I gave a paper to you. Instead of saying money, you are saying it is a paper. I gave a metal to you. No, not like that. So that metal inside the metal or inside that paper, you have a fictitious value. You are giving your hard work. You worked hard to earn that metal or that paper. You are giving that hard work to another person because he worked for you. Similar to that, the CAN is a method in which one electronic device is want to communicate with another electronic device. That can happen in different way. One among them is via this cable. If there are a method, there are some devices without any cable link between the transmitter and receiver, via wireless link, they can transmit bits. In that case, we cannot call that as a cable. So because it's a wireless, can we call that as something else? No. So the thing is, the CAN is a method to exchange information from one issue to another issue. That you have to understand. That can happen via different means, different ways. One among them is connecting issues with a cable. Another method is connecting via wireless link. Another method is connecting via fiber optic cable. There are many ways to do that communication, do that information exchange. But ultimate goal of this standard is to exchange the information between issues. Is that clear to you now?
Yeah, okay.
What is CAN now? Is it a cable?
It's a method.
It is a method. So that's why the people, instead of saying method, they say it as a standard. European way of saying method. Standard. So it is a way in which you have to exchange information between one issue to another issue. The CAN, in CAN, we don't have node addressing. That means a transmitter is transmitting to a receiver. So the transmitter knows to whom it is transmitting. This is like a node-based communication. Node knows other node to whom it is going to transmit the information. This is like other people cannot know about that. The transmitter and receiver, they are only communicating. Other issues in that network don't know about it. But CAN is not like that. When you exchange any information in the CAN bus, every node that is connected in that CAN bus know about that information exchange. Though that message is not intended to them, they know something is happening in the bus. There is an information exchange between some two nodes. At least up to that level, every node knows about the information exchange in the CAN bus. It is not like only two nodes know about it, rest of them don't know about that, not like that. That's why they are calling it as an absence of node. There is no specific one node is transmitting to another node, not like that. When a node want to transmit some information, it will simply put that information in the bus, that's all. When it put that information in the bus, whoever intended, they can take it and use it. Whoever don't want that message, they will simply ignore that. when the information is available in the bus, everybody know about it. Every node in the bus knows about that. Okay, something happens, some messages come. That is what the thing that we have to know about absence of node addressing. Non-destructive arbitration system by CSMA with collision detection. I used to say people can follows the concept of democracy. What does mean by democracy? The definition for democracy is for the people, by the people. So it was the people will select their leader from the people. That is how the democracy works. Everybody in that particular democratic system has rights to speak and then rights to defend for themselves. When the chance is provided, when the time is provided, when the slot is available, they can appear for their points. That's how everybody has equal rights in front of the law, though it is not practically true, but theoretically the democratic system is like that. So it says like everybody is equal in front of the law. Everybody has a right to speak when their slot comes. The same concept is used in CAN as well. When a bus is free, when the bus is free, because it is a communication, no? When the bus is free, every node in the bus has rights to transmit. They can come and they can try to transmit. If everybody has something to transmit, if they don't have, only one node has some information, he can come and transmit. But every node, assume your network has, your bus has some 4 or 5 nodes, all 5 nodes has some information to transmit, but only one can transmit at a time because it is serial bus, because bits are going serially one after another. When you have more than one people at the same time, you have a problem. Practically, you have only one way to go out, but you have 4 or 5 people. You have only one thing, but you have 4 competitors. Then what is the problem that you have? You have to find out who can use that. In competitive examinations, if 3 candidates has same score, they have same cutoff, means they will see their age, like no, whoever is older, he will get the chance, like that, because they are equal in the important criteria to distinguish, differentiate. In that, the cutoff itself, all of them having same cutoff mark. If that is the case, now the problem is, but the seat is only one. The MBBS seat, we have only one. We have to give only to one person. All 3 cannot use it. If that is the case, we have to find out another mechanism to remove 2 other competitors. They will use their date of birth, athletic certificate. There are many ways to remove competitors. They follow in that method. Similar to that, when the bus is free, every node in the CAN bus has a right to transmit. But they cannot transmit at the same time. As per serial communication, only one node can transmit at a time. Then what they can do, they have a mechanism called arbitration. Arbitration is a process. I will explain how that works, how they are able to remove the competitors. At the end of the arbitration, only one node will transmit the data. The arbitration will happen only when more than one node having a data to transmit when the bus is free. More than one node has the data to transmit. Among them, we have to find out the winner. they pick the winner based on the identifier that they have for their packet. The every packet that is transmitted in a CAN bus used to have a unique ID. As we have an Aadhaar number, every packet used to have an ID. Whoever has the ID which is having very lowest value, that will win the bus. How they are making that judgment electronically, I will explain that in detail in upcoming slide. As of now, the arbitration helps us to find out the winner. Why we go for arbitration? Because more than one node want to transmit at the same time, but in CAN, only one node can transmit at a time because it is serial. Do you understand why what is meant by CSMA and what is arbitration now, at least theoretically?
Yes.